This playlist deals with some aspects of Eurocode 2 version 2023. Watch this playlist for further selected topics. The video will deal with clause 8, ultimate limit state, and it's the fourth and last video regarding punching shear. You have different types of punching shear. First of all, you have the stirrups with closed loops or open loops. The anchorage of the stirrup must be completely fulfilled in the tension and in the compression zone. You can also use double-headed studs where the anchorage is adequate, or bent up bars. And finally, you can have single leg shear links. The different reinforcement perimeters must be situated at a distance of between 0.3 and 0.5 times the shear resistance effective depth dV, at a distance of 0.5 and 0.3 from the face of the support. The distance between two consecutive shear reinforcement perimeters must be smaller than 0.75 dV. For bent up bars, the angle must be between 45 and 60 degrees, and the first bar could be like it is indicated here on the drawing. For the radial spacing for foundation slabs, it's not 0.75 dV but 0.5 d, and the first perimeter of reinforcement should be between 0.2 and 0.3 dV. The spacing of the shear reinforcement is now explicitly mentioned in drawing, and you have two different types, which is the radial reinforcement and the orthogonal reinforcement. And for the radial, you have two zones, a zone which is at a distance of 2 dV, inside 2 dV and outside 2 dV. Outside 2 dV, the tangential spacing must be smaller than 1.5 dV. Inside, it must be smaller than 0.5 dV. For the bridge-like reinforcement, then now the rule is clear. It should be this distance smaller than 1.5 dV, and you have also two zones, 2 dV and inside and outside this zone. Drawing 8.24 tries to explain you the different reinforcement perimeters and control perimeters, but it's a little bit, it's getting a little bit confusing, because you have different type of perimeters. And for instance, on the drawing is mentioned B0 out. B0 out is by my knowledge not defined. So it's something which is not there. Or maybe it's omitted, the definition, but it's not clear in the text what B0 out is. You have, in fact, of course, B0, which is at the face of the support area. Then you have B0.5, which is at the distance dV over 2 from B0. Then you have B0S, which is dV out divided by 2 from B05. And then you have B05S, which is the which is in fact the the reference line or the perimeter where the reinforcement of line S is situated. And then you can have B05 out, that is the B0 verification outside the reinforcement area. So this drawing tries to explain the different use of all those control parameters and reinforcement parameters, and this for radial reinforcement and for crucifix reinforcement and for a situation like this one. Minimum shear reinforcement, rho min, must be applied, and it must obey this rule as stated in 12.4. The minimum reinforcement can be reduced by 10% for a ductility class B of the shear force reinforcement, or by 20% for a ductility class C. This formula of minimum reinforcement is in fact for beams, because you have S and BW. So 12.4 should read for slabs. When you have distributed shear reinforcement, inclined or not inclined, is the same formula, you will see that S and BW has been changed in the value that is needed for slabs. It depends, of course, of the radial and the tangential distance of the reinforcement legs. And for single bend-up bars, you have this formula to calculate the minimum reinforcement, needed reinforcement. There's also a maximum size of the shear force reinforcement, which is for single legs and open stirrups 10 times the square root of d over 200, or you can rewrite the formula. Closed stirrups, you will have this formula, and bent up bars and headed bars, you will have this formula. So in fact, when one is designing slabs, then you need a lot of information to make a proper design. The stirrup diameter, or let's put it this way, you can have a total slab depth, which is adequate for all the forces applied. And when you calculate the resistance for punching, it can happen that you need a bigger diameter of punching shear reinforcement, but this bigger diameter is not corresponding to the chosen depth of your slab.